Hello, this is Scott Hunter from the Azure Developer Experience team, and I'm here today to talk about the Azure PaaS, which is Platform as a Service, and Cloud Native Development. I've got an amazing group of people that are going to present today with us: Brady Gaster, Jeff Hollan, Mandy Whaley, and Paul Yuknewicz. And we're going to talk about how you can build modern cloud native applications on Azure PaaS, and talk a little bit about the future of Azure PaaS as well. To start off, a couple things. We're going to learn about the future of Azure PaaS, talk about where we are today, where we plan to go. We're going to show a brand new experience called the Azure Dev CLI, which makes getting started in the cloud easier than ever. You can literally run this single command, grab a GitHub repo, run it locally, provision all the resources in the cloud, and deploy to the cloud with one command line. Next, we're going to talk about Dapr. Dapr is an amazing framework to make building microservices easy. Today, you probably just build your own services, but you're not building those best practices in. How do you actually do retries? How do you do discovery? How do you do observability? All these things are built into Dapr, and it works cross-language. Really cool tech. Then we're going to have Jeff come and talk about container apps and cloud native development on Kubernetes. And finally, we're going to, you might have heard about low-code, Power Platform. We're going to show you how you can take any API that you build in Azure, put Azure API Management in front of it, and then after that, you can actually consume it from low-code, Power Platform, and we'll do a demo of that. Now let's get started and talk about where we are today. The world is moving to the digital space faster than ever. With COVID, work from home, it accelerated this to the fastest it's ever been. All of our technologies now work in a way that you can actually be anywhere in the world, anytime, on any device to do all this kind of stuff. So if you think about this, this is how I think of our vision at Microsoft. You can build a complete engineering system in just seconds. You can go to GitHub, click a few buttons, you've got your repo, you can contribute from any device. We have a variety of technologies like code spaces, which lets you actually develop in the web. That web could be on your browser, on a tablet, it could be on a computer. If you're using GitHub, you could actually be doing actions on your phone. And you can build for any platform. You might think of us as being a .NET company, but we use all the languages, all the tech. So you can build applications with our technology that works on Windows, Mac, Android, iOS, IoT devices across a variety of languages: .NET, Java, C++, Go, Python, et cetera, et cetera, et cetera. And this tech also lets you collaborate with anybody. We have features like Live Share, which lets you actually code together in any of those environments I just mentioned before with confidence, and we're going to let you scale this stuff to limits with Azure. Next, where are we today? Azure PaaS, Platform as a Service. You might have heard of Azure App Service. That's our primary Platform as a Service platform. You take your web code, you put it there, and it runs. And we actually patch the runtimes for you. We patch the operating system for you. The idea is to give you this really great usable model. But let's talk about what the first generation of these Platform as a Services are. As I mentioned a second ago, they're primarily web-focused. Whether it's App Service in Azure, Heroku, or App Engine, they're abstractions of VMs and IaaS. So under the cover, when you create an app service, we actually create a VM or an IaaS for you in the cloud, and we manage all that compute resource for you. You just have to worry about your application. But these things are tightly coupled to the cloud that you actually run them on. So if you're running App Engine, you're probably very tightly coupled to Google. If you're running App Service, you're tightly coupled to Microsoft. And so that's kind of where we are today. Now, cloud native, this is a term you probably hear all the time. And this is a way of building applications that run at scale across various clouds with new concepts. And there's a couple boxes here, like speed. Obviously, you want to build these applications as fast as possible. Agility, you want to be able to actually move across languages and technologies as fast as you can. Whatever's the best option for you. You want your app to be resilient, to stand up against stuff. You want all this tech to be easy to use. You don't want to have to read tons of manuals and stuff to use this stuff. You want to be able to scale it. You want it to be efficient, so it costs you the least amount of money, and you want it secure. So here's the things that we hear when we talk to customers. Productivity. I need to build and operate applications rapidly. Of course, this makes total sense. If you're inside of a company, you don't want to spend months and months and months and years. You want to build these applications super fast. Flexibility. You want to be able to build applications for any environment, including the edge, hybrid, and cloud. This means that I want to take the knowledge I have today and be able to apply it to, I want this app to run on the edge. I want this app to run on premise. I want this app to run in the cloud. You want those things to just come natural to you. Simplicity, this is what I expect as somebody that's been doing developer tools for a long time. I need a simplified and consistent platform to build my modern applications. The cloud's complex. So one of our jobs with a platform as a service is to give you all the building blocks. You don't have to go learn how to do authentication or scalability or diagnosability. They should all be part of the platform. Then patterns. This is an area that I think I want to focus on a lot more in the future, which is, I need prescriptive guidance on how to build my applications. We hear all the time customers build an application on premise, they move it to the cloud, and they have wobbles because guess what? In the cloud, the network might go up and down a little bit. Your data store might go up and down a little bit. I'm not talking about full outages, but I'm just saying these things might hop around a little bit. And using frameworks like Dapr, we're going to talk about later today, enables you to build a resiliency into that. It's a pattern. And we want you to use more of those things. And finally is consistency. I want to have a simple user interface across all of these things to run my applications. Now, as we think of the next generation of platform as a service, we want to make sure our platform as a service supports all the diverse workloads you might want to have, whether that's the web, it could be a serverless function, it could be a container, it could be a workflow, or an API. All of these should be available in this PaaS platform. We want to build all of this tech alongside open source. And that's so you can see how it all works, you can trust it, it's all right there. And so we want to do this out in the public with the communities. And then obviously, we're Microsoft, I work in developer division. We want to have an integrated developer stack. It's all focused on source control, Git-centric. It's got a streamlined developer experience. We have all the right IDEs, whether it's VS Code or Visual Studio or command line. And we want to give you the right patterns and prescriptive guidance of how to build these applications. And then finally, we want to give you the flexibility to run these apps anywhere. We know in many cases you can't move all your workloads to the cloud. So would it be great if you could run all these things like web, functions, containers on-premise if you needed to, or you could run them in the Azure cloud, that's my preference, or some other cloud if necessary. And so our vision is to build the most productive and performant platform for hosting modern cloud applications through a unified app platform. And we want this unified app platform to bring the best of cloud native and PaaS to every team. And so to start off, what I'm going to do is I'm going to introduce Mandy Whaley, and she's going to come and show you how we made getting started and taking your first application, getting it in the cloud faster than ever using our new Dev CLI. And with that, Mandy, take over.
Hi, I'm Mandy Whaley, and I lead our Azure DevTools team. I'm really excited to be here as a speaker at my first Microsoft build. As Scott mentioned, I am really excited to be here to share with you some of the new developer experiences that we're working on. One of the things that we've been thinking a lot about is this journey that we as developers go on from taking our code to having it up and running in the cloud. We start with our code somewhere in GitHub or on our local machine or another remote location, and then we have many choices to make. What cloud services should I use with this application? What libraries do I need to reference? How do I set up my local dev environment so it works great with my cloud deployment? Then I need to provision my infrastructure and services and configure the infrastructure and services. I need to set up roles and permissions so everything can talk to each other in a secure way. And I probably want to create infrastructure as code assets so that I can tear down and rebuild my infrastructure as needed. I need to run locally and deploy to the cloud. And then as soon as my application is up and running, I need monitoring and observability so I can troubleshoot what's going on. And ideally, I'd like to have everything in a nice CI/CD pipeline so that I can commit my code and easily deploy. But along this journey, there's many decisions to make, and it can be hard to discover the best practices that match up with the use case that you're building. And many times the examples that are out there stop at hello world, and you want to see applications that connect multiple services in a real life use case. So one of the experiences we are working on is a CLI-focused experience that helps you get from code to cloud fast. We're envisioning something like a command azd up, where you could select a template, in this case, a Node.js application with a Mongo backend, And in this one command, you would be able to provision your Azure resources, deploy your code, and have a working application that you can then start to modify, change, learn from, and extend. We also want to build Git-centric workflows, so creating CLI commands to help you set up a GitHub Actions pipeline and ways to get you straight to the monitoring and troubleshooting information that you need. The other thing that's important is that the templates that you can use with AZD Up are idiomatic to the language. So if it's a JavaScript template, it's going to have the frameworks and look the way a JavaScript developer expects. And we want to bring infrastructure as code into these projects right from the beginning so that you're always working in this way of being able to configure your resources from an infrastructure as code approach. One of the things that this experience really brings together is the packaging of this application code with the infrastructure as code assets, and then bringing in smart defaults, conventions, and best practices so that as you're using these templates and working through this experience, you're actually getting to see some of the best practices baked into the way that the templates are built. Next up, I'd like to take a few minutes to run through a quick video that takes a look at these commands in action. We're going to start with a quick start where you could find the command. These commands can be used standalone or as an extension to the AZ CLI. We'll take the command and run it in our favorite terminal, in this case, VS Code. This starts provisioning the resources, deploying the application, and you get a URL that you can click and immediately see this application up and running in Azure. And all of this code is available on GitHub. It's important that you can see exactly what the up command scaffolds for you directly in the repo on GitHub. And this includes all of the application code, all of the infrastructure code, everything you need to run locally and in Azure, as well as supporting your DevOps workflows, the multiple environments, and everything that you need to be able to modify and redeploy. It also comes with a developer CLI, which ties together this end-to-end workflow with simple commands like provision, deploy, workflow, and monitor. Every sample comes with a README, which describes the use case, the application being built, all of the Azure services that are used, and walks you through step-by-step everything you need to do to get up and running, and then go beyond with additional commands like workflow create and monitoring. Now let's take a look at what happens when we run this command. We're back in VS Code. I'm going to run the command. It prompts me for a name for my project. I'm going to accept the default, but you can easily change it. After this starts, I'll see that my files are scaffolded out in the project. I'll pick my subscription and the location where I want to deploy the resources. Now the Azure resources are provisioning. While that's provisioning, let's take a look at some of the things that are in the application template. We'll start with the infrastructure folder. This has all the infrastructure as code files that describe the Azure resources and everything that's needed for the application. Each one of these files follows a common pattern, and it's always in a folder called infra. This is on purpose so that it's consistent, it's repeatable, it's easy for you to build on and extend. The next folder we want to take a look at is the source folder. This is where the application code lives. And what's important here is that the application templates are built idiomatic to the language, so it really meets the expectations of Python or JavaScript developers. In this application, we have a web application and an API layer. The next section are the files that help us build the GitHub Action workflow files. And then there's an azure.yaml file. And this is what connects the application code with the infrastructure as code files. It ships with intelligent defaults for hosts and names, but they're easily configurable and changeable. Now let's take a look at our application that's up and running in Azure. So you can see we have a link that we can click directly on, and it will take us and open up that application in our browser. We can see it running. And then we can start to look at all of the Azure resources that were provisioned in the portal. So we do have an application. We have a web application, an API, a database, and then also the monitoring all set up for us in Azure. Next, we want to create our GitHub Actions pipeline. So we'll use the workflow create command. This will help us set up our GitHub repo if needed, as well as helping us with the service principals and secrets so we can securely set up our deployment pipeline. Monitor command is going to take us right to that dashboard, which really helps us see what's going on with our application. And another tool that we're working on is integrations with VS Code. So if your favorite way to work is through VS Code, you'll have everything you need to work in your favorite style. These experiences are some of the new things that we're working on. Right now, they are in preview, and you can get involved in this preview at the link below. Once you're enrolled, you'll be able to try some of the first solution templates that we have, give feedback on use cases and services and languages and feedback that you would like to see. You'll also be able to take one of your own projects and enable it to work with the developer CLI. We're really looking to build this with the community and really looking for your feedback and how we can create tools that speed up your code to cloud journey. Next, I would like to turn it over to my friend Paul, who's going to take us through some of the new microservices experiences.
All right, thank you, Mandy, so much. So I'm Paul, and I'm here to talk to you about building modern applications that use microservices and distributed application concepts. And we're going to introduce something a bit newer called Dapr. So Dapr is motivated by backend and distributed app developers who are trying to do best practices but find it very challenging. So for example, when we build microservices and we build backend APIs, they need to be secure. We have services calling other services, and at scale, there's a lot of resiliency and fault tolerance issues that can come up. And there's new emerging patterns that you want to use to offload state and to do some best practices with state management and also secrets. So these are the kinds of things that we want to do. And there are solutions out there to help with these microservice patterns. However, what we've experienced and what our customers have experienced is that there's really just disjointed tools and runtimes and ecosystem around this, oftentimes tying you into a very particular language or a very particular runtime, and that puts a very tight control around what you want to do. But what we've learned is that portability is also extremely important as we move these applications and APIs through a modern DevOps process. So what we've done is we've worked on, together with the community, on something called Dapr. Dapr is simply Distributed Application Runtime. It's not just a cute name, that's what it stands for. And Dapr is really a programming model that makes it easy to do these best practices for back-end distributed applications and for microservices. And some of the things that are really cool about Dapr is it really was built with portability in mind. So at the end of the day, it looks like a set of APIs exposed through a sidecar process, not a container, it's actually a process. And what you can do is you can call them RESTfully through HTTP or through gRPC. And then we have a really nice programming model and layer on top of that using a set of SDKs that would be in your favorite languages, you know, whether it's .NET C# or Python or JavaScript or Go or Java. So, you know, bringing that all together, you get that easy programming model, you get the portability, and you get a form factor that can run just about everywhere, whether that's VMs, Kubernetes, or in PaaS. So let's focus on two patterns that are really common when you're doing back-end programming. You know, one is just simply you have not only a service that does its own work, but you have services interacting with other services. And really that's what it's all about in a distributed app. Also, once we get more into asynchronous programming, you start to do these publisher and subscriber, pub-sub kinds of models. And these are probably the most two common things that I think developers start with, and I want to focus on those today. So let's look at that in Dapr. The first thing we'll look at service invocation. So I have two services. I have my app, and I have a dependency, service A, that I'm calling. And all I have to do to call it is I RESTfully call the service, and I pass my data payload. And you can see that those Dapr sidecars are acting as kind of as middle people that are intercepting and helping add value with middlewares and doing extra functionality. So here we can actually add MTLS encryption to every single backend call. We can add resiliency logic, like we can add retries, circuit breakers, timeouts, time to live. We can add service discovery. We can add observability. So by having those sidecars, it takes your existing code, your existing app, and makes them a lot more powerful, and you can use this RESTful programming model. Now, let's think about it in C#. A lot of us use the HTTP client, and that's code that we don't want to have to completely rewrite just to use Dapr. So all you have to do to start using service invocation is you can go ahead and just add a header. So we're showing the Dapr app ID header. Set the name of the target service you want to call, let's say in this case order processor, and then your HTTP post code will just start using Dapr. and it will dynamically get that service discovery and all those other middlewares in between, like MTLS and things like that. So this is a really incremental way that you can start using Dapr. But I've been bragging a little bit about the programming model. Let's show a little bit more what that looks like. So now we'll go to the publish and subscribe pattern. And here what you would often do is you would have a client that publishes orders to a topic. A topic is kind of like a tag that you could filter on. And on the subscriber side, we'd have multiple consumers of that topic. And they're going to subscribe to those messages and kind of work with the data. And then in between, we usually have some kind of a message broker. Here I'm showing Redis, but it really could be a lot of things. It could be service bus, event hubs, it could be Kafka, it could be a queuing system. There's just so many. And the cool thing is with Dapr, you just use the single programming model. You just publish your data. And no matter what the backend or the broker is, just through config, you can bind to the one that you want to use. And that works across environments. I could use Redis locally. I could use Service Bus in Azure. Let's look at this again through code. So here, I want to pass an order as my object, and I want to publish it. And now I get down to a one-liner. So I use the Dapr SDK, and I have this client object. I just publish async, and I can pass in the order. And that's really all I needed to do. Notice I'm not writing code that's specific to Redis or to Service Bus or any backend. That's that portability that I'm speaking about. We just deal with that through config. Okay, so now that we've seen the programming model a little bit and a few of the patterns, let's jump into a demo. So what I want to do here, I've been working with my team, with Mandy and Jeff and Brady and others, and we have this cool podcast app. Maybe you've seen us work on that before, but I thought it was time to add a feature that helps make the podcast a bit more accessible, and I want to do that by having transcripts. So what I've done is I've written a microservice, and my goal was, how can I knock something out in an hour now that I've got this extra hour and I can take this feature off the backlog? So I wrote the transcript microservice in Python, and I used Azure Cognitive and AI services to basically take the transcript as a file in, using an MP3 or a common WAV format. And then I used the Cognitive APIs to basically generate a transcript, which, as a first approximation without a lot of training, is actually going to give me a pretty good result. Let's go ahead and run it and just see how that looks. So I'm here. I've got my WSL environment that I'm working in, which I love. And we'll just say, we'll use the Python runtime. We'll fire this service up. All right, so it's running on this port. And let's open up my little test harness. So I've got an HTTP file, so I can do the curl equivalent. I can just throw a post at it. So let's send a request. Now I can see that we're analyzing the podcast using that Cognitive API, and boom, a few seconds later, I have that transcript coming back as text. And not too bad for just a little bit of work in one function that does that. So I've got a microservice, but as we've spoken about before, it's really about distributed apps where services call other services. So what I want to do is wire this back into my bigger podcast application, and a lot of that's written in .NET 6 and in C#. So I want to build that interaction. Given that it's .NET code, I'm going to open Visual Studio, and I can see here that I'd written a function, and the function is based off of HTTP code, but I've just added really that one-liner that I spoke about before. We're going to add a request header that sets the Dapr app ID to transcripts. That's the target service that I'm calling. And then we're just going to use the same post async that we were using before. And thanks to Brady taught me to use environment variables. So I can just change the environment variable for my base URL to point to the Dapr sidecar. And then we'll go ahead and run this. So I'm in the podcast transcript function. And what I usually do, if I can find the command, you're going to have to watch me freeform it. All right, you'll watch me freeform it because that's fun. So we're going to do a Dapr run. We're going to pass in the app ID, and we call it transcripts. That's all we need to do to start the service and give it a name so that it can be found through service discovery. If we have any optional config, we'll grab that from this path. And then we'll just call the executable the way that we're used to calling it. So with a function, I would say func start and then this is C#, so we just make sure it finds it. We'll go ahead and run. Okay, so we're up and running. I can see that Dapr loaded the sidecars and set up my componentry, but also I'm loading the function's runtime, and the function's runtime is actually starting the function. So you can see it's really easy, again, to take existing code, to take an existing architecture like a function, and then go ahead and add Dapr kind of incrementally on top of it just by doing the Dapr run and by passing in the header. Okay, and so we've got that function running, and we're off to the races. Like, if I were to check that, I could say Dapr list using the Dapr CLI, and I can see that this microservice transcripts is live, and I can call it at any point using this app ID. One more thing I want to point out in the code. It would be really easy to use the Dapr SDK at this point and add more features. Like, I can add state management just by calling Dapr client, save state async, and pass in the data from the transcript. Looks like I should give it a topic name. I think I was just in the middle of writing this. So we'll give it a key. I would use something unique, but just for the sake of the demo, we'll pass that. And then also I want to send a notification saying, hey, there is a new transcript, and here's the data payload for that. So I can have downstream clients, I can have other services that do something once that transcript is available. The very last thing that I want to do, I want to add even more features. And the cool thing is I'm not going to write any more code for this. I'm going to go and I'm going to lift some config for resiliency. So here's one that my colleague Nick gave me. I'm just going to throw that in there. And so if I open this resiliency YAML config, I can see that we've set policies for a timeout of 5 seconds. I want to have 5 max retries, each with a duration of 5 seconds. I could add a back-off policy if I want that too. And I'm going to have some circuit breakers, because if we don't want to overwhelm the system, we can actually have a circuit break, and then we can handle the circuit while we take a microservice out of rotation. So these are patterns that, honestly, I would not be going home early for dinner tonight. I would be late for dinner if I tried to code these myself. These are kind of hard problems to solve with microservice interactions. And just by using Dapr, by dropping in a stock config file, my existing code will now start doing these patterns. And you can make it adhere to one or more or all of the APIs in Dapr. Observability and a number of other features that we have are just like that. I can drop in a YAML file, and I'll start using Zipkin or OpenTelemetry or App Insights. So we've added that feature, and really just the last thing to do is to commit this. So let's do, let's add these files, and we'll go ahead and commit it. Helps to get the right branch. All right, perfect. And we're off to the races. So now this code is teed up. And Jeff, I'm hoping you can help me take this to the next level in the pipeline.
Awesome. Thank you so much, Paul. I'm excited to continue to talk to you. And I want to talk a little bit about where you can host these cloud native and platform services in Azure. So for those of you who have Azure before, you're probably very familiar with our Azure Application Platform. What makes this so exciting for developers and useful for developers is that each of these services are purpose-built to help you in accomplishing common tasks. And they're built on the latest and greatest tech to give you performance, security, and reliability. So if you need a website running, whether that's an ASP.NET website or a Java website or a Python website, you can use services like App Services and get those capabilities out of the box. Or for event-driven data processing workloads, Azure Functions. So this suite of technologies is incredibly useful to just get your code up and running. One of the things that I love about the Azure Platform Services is that you can choose to run these on containers when you need, or if you just want to deploy your code, you can do that as well. One of the things we've announced recently is the ability to run these application services anywhere through Azure Arc. So you have the flexibility to use the tools and capabilities of services like Azure Functions, App Services, and API Management, but the flexibility to run them anywhere. But we realized that we needed to add to this story, and we wanted to make sure that we were supporting microservices as well, and enabling capabilities like what Paul just showed with Dapr, which is why this week at Build, we're really excited to share that Azure Container Apps, our newest entry into the Azure PaaS family, is now generally available. Azure Container Apps is a fully managed serverless service that enables you to run your containers and microservices within Azure. What's powerful about Azure Container Apps is it's built entirely on open source tech. There's no magic behind the scenes. Every container app is powered by Kubernetes, popular open source tech like Kata and Dapr and Envoy. But as a developer, I don't have to worry about learning all of those technologies directly. I can just get started immediately writing my apps and my containers. These are great for a number of different workloads. So we see users building websites and APIs, minimal APIs. One of the things I really love about container apps is you can run background jobs too. So maybe you have a container that's listening on something like a queue or an event hub, and you've written a .NET worker that's responding to that queue or event hub. You can run that in container apps as well. We'll dynamically scale it, including scaling it all the way to 0. And when container apps is scaled to 0, you don't have to pay any money. So this is super efficient, not just in cost, but also in productivity. You can get started right away, and we'll show you in just a minute of what that development experience looks like. So as we look ahead at our platform services, we want to bring the best of cloud native and the best of PaaS together, as Scott mentioned a little bit earlier. So that means making it so that you have rich local development experience, so that you might have microservices applications, maybe a web app and a function and some backend containers. I want to be able to build them all together, leverage technology like Dapr to weave in those best practices. We're going to be developing a number of templates and accelerators to help you in creating those solutions. And in terms of the management side as well, we want to provide ease of access. If you choose to use a container, we'll help you to secure those, to maintain them if you choose. And if you just want to use code, that's fine as well. What's great about this too is because if I think about technology like container apps, because it's built entirely on open source like Kubernetes, gives you the flexibility to choose, maybe I'm going to start with container apps, but I could take that exact same solution, those same containers, and move down the stack as needed to potentially take my container app solution and now run it on top of Kubernetes. So let's go ahead and show that in action now. I want to pick up from that story where Paul was showing of microservicing and Daprifying some microservices, and let's go ahead and run this now in the cloud using container apps. So now I have this podcast solution, this set of microservices. They've been Daprized. I can run them all locally. Now I need to run them in the cloud. So that's the question. How do I get these different services that I have here in Visual Studio running in the cloud? Well, one of the best places for me to run my microservices is the new Azure Container Apps, because this is a fully managed serverless platform, all powered by Kubernetes behind the scenes, where I can run this application. What's great is within Visual Studio 2022, we have integration directly within the Publish button. So I can right-click any of these containers, choose to publish to Azure, and even choose to deploy to Azure Container Apps directly, now generally available with everything that I need to get this container up and running. Now, I'm not going to use the right-click deploy in this case, because what I've actually chosen to do is, you'll notice I've wired up some GitHub actions. So I've decided instead what I want to have happen is whenever I make a code change to this application and check it into Git, that's going to go ahead now and deploy a series of actions in this repo that will go ahead and deploy and build this solution to my subscription. So I now have a solution where I make a change, it'll build those images and push them into my Azure subscription. So what does that look like? So here in my Azure subscription, here's those container apps that are getting deployed to from that Visual Studio project. These have Dapr enabled. Let me show you a few things that I love about container apps. One of them is that it's going to provide for me this endpoint out of the box to hit these APIs. I can change this with my own custom domain, but you'll notice right here, this is HTTPS. This is giving me certificates and domain routing and traffic routing out of the box. I don't have to worry about managing the underlying infrastructure here. I can focus just directly on the apps that I have, manage the secrets for my apps, manage that continuous integration. I even have some monitoring here so I can see how this app is behaving. One of the other things I really like about container apps is the ability that I have to deal with scale. So I can come in here to this latest version that we've published, and I can go ahead now and modify the scale rules. So I could, if I want to, scale this all the way to 0, which means if this doesn't get traffic for a number of minutes, we'll scale that all the way down to 0. When it's scaled to 0, I don't pay any money on my bill. So I only pay when this container is actively processing requests. And I control maximum scale as well, or maybe I'd want a minimum to reduce latency. I can also set up a number of different scaling rules on event sources like queues or event hubs or databases, or in this case, you can see I'm using an HTTP scale rule to determine how many concurrent requests each of these containers can have. So I now have my certificates, my traffic rules, my container running in a fully serverless environment. So here now in Azure PaaS is powering this podcast app. It's calling these background microservices through Dapr, all now hosted in my subscription. So that's great. Container Apps has made this super seamless, super developer friendly. Now, what if I want a little bit more control though? What if I started with Container Apps? This is really great, but for some reason I've decided, okay, I need to run this in a different environment. Maybe I need underlying access to some complicated Kubernetes APIs like daemon sets where I want to run custom jobs. In fact, I want to get the same application architecture running on a Kubernetes cluster in Azure, this Kubernetes cluster right here. So what's great about how I've built this with microservices and Dapr and Container Apps is that the entire time when this has been running in Container Apps, it's been running on Kubernetes. It's just a Kubernetes cluster I haven't had to worry about. What that also means is that I can come here. In Visual Studio Code, I've actually gone ahead. I've done a little bit of work. I've created some Kubernetes deployment manifest. I'm using the Kubernetes API to define a bit of YAML to explain how my solution works together. And so this has created what's called a Helm chart. This is like an install file for Kubernetes. But what that means that I can do is I can take the same application, the same code, and I can say Helm install my podcast app. And this is now deploying all of that Kubernetes configuration for the same app code, the same containers, but now it's deploying to my own Kubernetes cluster. So I've gone ahead and connected to that cluster. I'm going to use the Kubernetes command line. I didn't have to use this before when I was using Container Apps, but here now I want that extra control. So now I can poke into that cluster. I can see how these applications are running together. I see here's my podcast API, here's my podcast web front end. And if I refresh this command one more time, we should see it's given us an IP address. So I'm going to go ahead now and back into our browser. Let's go to this IP address that's now running in this Kubernetes cluster. Okay, there we go. This is the same application. You can see it's the same app as before. This tab is running in Azure PaaS, fully managed for me. This tab, I'm saying, you know what, I'm going to run it on Kubernetes directly, but I haven't had to change the code. I haven't had to change the containers. So now I have this additional access, this additional controls, some additional knobs when I need them. This gives folks the confidence to know if they need to move down the stack, they can, because throughout the process in Container Apps, I was running on Container Apps. And now I've chosen to move into a model where I'm going to be managing and monitoring and controlling a bit more. So super excited what folks can build with Azure PaaS and the new Azure Container Apps, now GA.
Now this is a story we want to continue to improve and continue to make even easier for every team. Really excited to share more with you in the future. But for now, I want to hand it over to Brady, who's going to talk about how we can extend these solutions with Power Apps.
Thanks a lot, Jeff. I'm Brady Gaster, and I'm here to talk to you today about how to take your APIs into Power Apps, so you can build front ends and all kinds of business apps and Power Automate apps on top of those APIs that you have running in Azure. So you'll see here that what we're going to talk about is empowering low code to pro code. So what we want to do is I've got my API that I wrote in Visual Studio. I'm probably deployed using GitHub Actions. And what I'm going to do is I'm going to import that API into Azure API Management. And once it's in Azure API Management, I can integrate it with all kinds of things like Power Automate, Power Apps, Logic Apps, and even third parties. So what I'm going to do is I'm going to flip over to a demo. So you'll see here that I've got a Swagger UI. That shows you that I've got a minimal API using ASP.NET Core on the back end. I've deployed this out to Azure Container Apps, stuff you saw Jeff talk about earlier. You can see that I can go ahead and test this and get back some data. See, that's my URL. What I'm going to do is I'm going to copy that Open API URL to my clipboard, and I'm going to open up the Azure API portal right now, API Management portal. And I'm going to go into my API Management instance inside of that resource group in Azure. And what you'll see is that I currently don't have any APIs in there. So the first thing I'll do is I'll go ahead and click on the New API button, and I'll go ahead and import an Open API. I'll paste in that URL that I got earlier. I'm going to change the name here to .NET Podcasts, because this is our .NET Podcast app, obviously. And once I've done that, I'll go ahead and hit Create. And what will happen is we'll import that Open API directly into Azure API Management. You'll see all those methods right here. So I'm going to click on this Get User Submitted Feeds item, and that's the actual method that I've got. And you can see I've got inbound and outbound processing. I can set up my APIM portal to do all the security. What I'll do right now is I'll just hit Test. And that's actually going to show you that API Management is reaching out to that Azure Container App, making an HTTP request, and then bringing that data back. So now I'm going to create what's called a Power Apps Custom Connector. I'll go ahead and hit this Create Connector Export button. I'll give it a name. Just call it .NET Podcasts. Just hit Export, and you'll see it's already exported over to Power Apps. So I'll open up Power Apps. And first, I'm going to make sure that that's been exported. I'll go over here to my Custom Connections. You'll see right here, there's that .NET Podcast Custom Connector inside of API, inside of Power Apps. Now I'm going to edit this Power App that a friend of mine, Julie, has been working on. You'll see that I've got a couple of errors because we kind of made an agreement on what we were going to call the different variable names. So the first thing I'm going to need to do is to connect this application, this Power App, to that custom connector that I just created in APIM. So you'll see that I've got a collection right here that I've got all my stuff data bound to, but that collection is currently empty. And you'll see that I've basically just got a data grid there that kind of shows all the stuff that I'm getting back from the API. So really quickly, I'm going to type in podcasts, select that podcast connection, hit connect. What that's going to do is that's going to create this connection in my Power App, and I'm going to rename that to the agreed upon variable name that we have in the Power App here. You'll see everything just got fixed because it automatically sees that I've changed that variable name, and now it actually knows how to reach out to that API. So what I'll do now is I'll just type podcast API. You'll see that I've got all the methods that I found in my APIM portal. I'm going to go ahead and copy that out. Now I'm going to call clear collect. And what clear collect is going to do is it's going to clear out that collection of data, currently doesn't have anything in it, call that API method, and refill that collection again. There we go. And now I can just run the app. At this point, I'm going to click the robot's face, and we've got data. So that's the Power App, reaching back to API Management, calling my Azure Container App, running my minimal API.NET code, and then bringing that data back. So you can see that's pretty much how we wired it all up. And now what I'll do is I'll go ahead and set the onVisible event handler here. I'll just paste in that same code so that it'll load whenever my app runs, and that way a user doesn't actually have to click the robot's face to actually get the data back. And now you'll actually see that I can actually call the delete feed, passing in the ID of the selected thing. You'll see that's all the code that we already had wired up. We had agreements on what we were going to call those APIs. And you'll see now when I actually hit the delete button, we'll delete that feed, go ahead and approve this one, delete that one, I'll go ahead and approve it. And then we'll just go through the rest of these and just make sure they're already, all the feeds that users have submitted have either been deleted or approved and imported into our podcast system so we can go and listen to stuff later on. Go ahead and approve that one and this one, and pretty much get all the way down to the bottom. See, each time we hit one, we've only got the pending is actually going down. And then if I go back over here to my API one more time, see right here's that podcast API, and there's the methods. All right, so what you see me do there is I was actually using Visual Studio to build my API, and then I deployed it out to Azure, and then I wrote a Power App, and that Power App connects to my API. But what if something goes wrong? In that case, I've got my Power App running on the internet, but I've got my API running locally. So I want to show you a little innovation that we've got coming out very, very soon that will enable that very scenario for being able to debug your APIs when they're getting hit from clients on the open internet, like Power Apps. So here I have my Power Apps environment. What I'm going to do is I'm going to open up this dev copy. This is the app I'm working on. And what you'll see when I go ahead and run it is it's making a call out to an API. I've right-click deployed this API out, and within Visual Studio, I've got the ability to include an APIM deployment. So I've ingested my API in the APIM, and so far it seems like things have been working, but I got to report that there's an error on it. So I want to try to figure out what's wrong. And so this delete feature seems to be working, so that will actually delete it. Because now I've got 6 pending, whereas a minute ago I had 7. So now I want to go to a different one that I want to approve. And, oh, yep. Looks like we got some kind of an error message. So I'm going to need to figure out what's going on here, see if it's just that issue or if it's all of them. I'll click this one. Yep, looks like I've got some sort of a bug in my API. So I'm going to need to actually debug the API with this Power App, which can be a little bit tricky. I'll bring over Visual Studio here. And here's my actual feed endpoints extensions, which is really all the different feed endpoints. And the one that I'm going to have to debug is this one, this put, because that's where we're actually updating the user-submitted feeds. I'm going to put a breakpoint right here and hit F5 and just kind of see if I can debug it. But it's probably a familiar problem whenever you've got to debug an API that's getting hit from an external, client, is that whenever you hit F5 on it, you're going to be debugging, on localhost. So it's kind of hard to actually hit it from, something like a Power App or something running in the cloud. The good thing is we've enabled a new feature, port tunneling, in Visual Studio, and I'll go ahead and create a couple of additional settings in my launch settings file here. One is create tunnel, I'll set that to true, and the second one is to give it a tunnel name. And now when I hit F5, when I debug my API, rather than debugging it on localhost, we're actually going to open up a public tunnel back to my localhost machine and give myself a public DNS that I could actually drop in any kind of a cloud provider, any client, and hit it. So you can see there's my fully qualified domain name. That tunnel that I asked for, subtunnels.api.visualstudio.com. Now, I'm using API Management, in Azure to deal with my custom connectors and Power Apps. So what I'm going to do is I'm going to paste this URL, which is now that tunnel, back to myself into this API Management instance. This is the actual API Management instance that I just deployed to from Visual Studio, which we're using as a custom connector. And you can see when I hit the Get User Submitted Feeds, it's working. Just to kind of make sure it's working, I'm going to put a breakpoint right here in that method, and I'll go back over again and hit send. And yep, looks like we are now directing traffic from that APIM front door back to my machine through the new feature of Visual Studio called port tunneling. So now what I'm going to do is open up my Power Apps client here one more time. I'm going to go back into that dev copy of the app that I'm working on. And now you'll see got 6 running here. And I want to go ahead and try and approve one of these with my breakpoint set inside of that put method. And look, there you go. And I can see, oh, that's what's wrong. So I'm passing 2 parameters to that find method. It looks like I'm passing ID and cancellation token. Like maybe I copied and pasted those parameters and didn't think about it. I'm going to go ahead and back that out, get rid of that cancellation token, and just pass ID. And now I'm just going to hit the debugger again. This is definitely going to stop my Power App from running, but that's okay. I'm the only one hitting it. It's my dev copy. So now what I'll do is I'll go back over to my Power App again. This is my browser opening up that we're running in that tunnel. And since I'm running in the tunnel and the APIM is hitting my machine, I can hit this and we'll tunnel right back to my machine. You can see there's that ID that I just sent. I indeed found that feed, and now it looks like things are working. So we're good to go. It looks like it's going to remove that feed from that context, and now we're off and running. So now I can go down, I can try another one here, make sure things are good. Give that one a continue. Try one more with the debugger running, just to kind of make sure things are all good. See here, all right, that looks good. Go ahead and remove this debugger, and I've got a couple of these feeds that have been submitted. I'll go ahead and approve these. Actually, that one. Go ahead and approve this one, approve that one, and now we're done. We're good to go.
So what you saw there is how we're not only empowering low-code to pro-code, but we're also enabling API developers, pro-code developers, to be able to debug their applications from those internet front ends and those Power Apps and Logic Apps. That enables a totally new ability for you to debug stuff and figure out what's going on without having to deploy code and do a bunch of logging. So with that said, Scott, I'm going to hand it back to you.
Thanks, Brady, for that awesome demo. I just want to talk about the takeaways one more time now that we've done all the talk. First off, we talked a little bit about the future of Azure PaaS, where we want to get to in the future, and that'll be a very near future. Secondly, we showed the amazing dev CLI. You can see how you could go from 0 to code on your box to code in the cloud in under 10 minutes. Then we talked about Dapr, which is a framework you should be adopting today. Even if you're on-prem, it's the best way to have your code be ready to go to the cloud and be resilient in the cloud. And then we talked about Container Apps, which is a great way of being able to run your workloads on Kubernetes without having to manage that Kubernetes. So we give you all the benefits of Kubernetes without having to manage that Kubernetes. And then finally, we showed you with API management, you can take any API that you're running in Azure and you can make it available to the Power Platform, the low-code developer. So thank you so much for attending for watching this show today, and please try these techs out right away and give us feedback. Thanks.